Hi, everyone. Welcome to the next generation of Fluke Calibration. We are really excited with what we have here to share with you today. Our engineering, product, and operations team have been hard at work in developing the next generation of calibrators for our labs around the world. So let's take a look at the last 10 years of what we've come out with so far. In January 2014, we released the 5730A, the standard for multifunction calibrator performance. In August 2015, we released the 5790B, which was the easiest way to make precision AC measurements. In March of 2019, we released the long scale DMM, the 8588 and the 8558. This was the world's most stable digitizing multimeter. And last year, we released the 5540, 5550, and 5560A. The multi-product calibrator was defined an entirely new class of multi-product electrical calibrators and was groundbreaking equipment for calibration labs. And then in August of last year, we released the multi-product calibrator with the scope option, which has been enjoyed by many. And today, we want to launch the next generation dedicated scope calibrator. So introducing the 9500C. The 9500C supports up to 4 gigahertz of bandwidth. Improving over the 9500B, it's 30 to 40% faster in overall test time. There's improved active head technology, there's improved serviceability and reliability, and the 9500C is the most efficient, effective, and productive scope calibrator on the market today. So let's take a look at what it looks like. So on the front, we have this beautiful new touchscreen display improved over the 9500B. This is the same display that you've seen on the 5730, the 5790, and last year's 5560. It is intuitive, it's new, and functions are all in the same place as the 9500B. The soft buttons on the bottom allow you to change depending on the context and depending on the function that you want. So all the information that you need is right there, right at your fingertips. On the left-hand side, you have the active head control and that the analog output signal connections. These are newly designed to provide you better signal output. On the right-hand side, you have your standard keypads, your output function buttons, your start and stop buttons, as well as your operate and standby buttons. And lastly, on the bottom there, you have a USB port, which provides quick and easy ways to provide firmware updates, along with the new rubberized handles, as well as the on-off button there in the corner. This is an entirely new system using the same design language as our 5730 and all of our calibrators that we've released in the last 10 years. On the back, you have a universal power input, you have a chassis ground location, you have an area to provide an auxiliary input so that you can have a pass-through signal to any of the channels. You also have an area you have also an area to input frequency references to allow for precise synchronization, as well as another USB slot and then a location to have your GPIB and LAN for remote control. So how is this different than the 9500B? The 9500C goes up to 4 gigahertz. The 9540C has a has fast edge of 125 picoseconds. Every single function except for edge and marker can provide simultaneous output into all 4 channels of your of your oscilloscope. The signal accuracy and fidelity is better. It is more serviceable. And like I mentioned before, there's that beautiful 7-inch color display with touchscreen. So let's take a look at the specs. Let's see how really the 9500B with the 9530 head compares to the 9500C with the 9540 head. It's better in DC volts, square wave, edge function, leveled sign frequency, leveled sign amplitude, leveled sign flatness, as well as pulse width. Overall, the 9500C with the 9540 head has better performance, is more efficient, it's more effective, and more productive than the 9500B. Let's take a look at what our product manager, Wally Miller, had to say about the product.
The 9500C is efficient because it provides all of the signals that you need to validate and verify and calibrate modern oscilloscopes. It's effective because it provides very high levels of signal quality and purity right at the connector of the oscilloscope. And then it's productive because it has 4 channels, and we can drive all 4 channels at the same time, effectively reducing test time by a factor of 4. Hi, my name is Wally Miller. I'm a product manager here at Fluke. I manage our electrical calibration range of products. The 9500C uses active head technology. It allows us to tune the signal directly on the oscilloscope, delivering the highest purity and highest levels of accuracy without having to worry about losses through connections and those sorts of things. The 9500C is more accurate and has much higher signal purity than its predecessor, the 9500B. If you've been using the 9500B, switching over to the 9500C will be absolutely seamless. Buttons are in the same place, functions are the same. It's just a much easier to read, more modern user interface. It retains all the familiarity that you gained or you learned with your old 9500B experience. If the 9500C is new to you, the beauty of it is that it provides all of the things that you need in one box. You'll still have to understand how to calibrate an oscilloscope, which is probably more difficult than it is to use the actual calibrator itself.
It's really, the 9500C is really an outstanding machine. It is your key to exceptional signal performance. When calibrating oscilloscope trigger, when calibrating oscilloscope trigger sensitivity, the dual sign output reduces the need for splitting cables, reducing total calibration time. You can easily switch between 1 megohm impedance and 50 ohm impedance and quickly match the impedance of your oscilloscope without any additional equipment, improving the automation capabilities. With the accuracy timing markers plus and minus 0.25 pp parts per million, this reduces the errors while maintaining the level required to calibrate today's DSOs. You can calibrate current probes and trigger level matches, trigger level markets using and you can use composite video signals to test TV sync separator functions. You can, as I mentioned before, you can route your own waveforms from external sources into any active head that you want, allowing you to improve the capabilities of your calibrator. And more importantly, you can fully automate with MetCal. Starting from the release, you can use your 9500B procedures directly onto the 9500C. Once you develop your procedures, of course, we'll release our own, you can fully use the simultaneous output capabilities of the 9500C. This is the most efficient, effective, and productive scope calibrator on the market today. Let's talk a little bit about the active heads. The new active heads have improved performance. You can control the trigger and up to 4 channels simultaneously. This allows precision DC voltage measurement up to 220 volts. You can calibrate square waves up to 210 volts peak to peak from 10 hertz all the way up to 100 kilohertz. You can calibrate leveled sine waves from 0.1 hertz all the way up to the 4 gigahertz limit. The complete automation with MetCal, you can just connect your scope and walk away while the machine calibrates and does the work for you. A single technician can now cover a broader workload at once. Once the scope is connected, say you have 5560 on the other end, your technician can then use the 5560 to automate and calibrate the DMM, bring him up to do other work around the lab. The 9500C, paired with our newer calibrators that are in the market today, they give you the complete ability to automate your scope calibration. I'd mentioned before that the heads themselves have better service and better reliability. The new active heads have a better, more resilient design than we've seen before. We've heard your stories of sending your 9510 heads and 9530 heads and the long times for serviceability, and the cables are always an issue, and so is the BNC connector. With the 9540 heads, the BNC adapter, the analog signal cable, and the digital control and power cable are field replaceable. This means if a cable gets worn down, an adapter gets worn down, you can replace the cable in your own shop. There's also improved internal components with the head itself. There's more solid state components. And the amount of relays has been reduced down to just 2 to reduce any mechanical failures within the head themselves. Overall, the 9540 heads with the 9540C will provide higher uptime and improved performance in your calibration labs. Lastly, to make the best use of your machine, we have improved bandwidth and signal purity, making the testing a lot more precise. I've already spoken about the automated switching between the 50 ohm and mega ohm impedance, and it's done at the active head without any additional equipment. And we're seeing close to perfect VSWR outputs. We're seeing less than 1.1 up to 550 megahertz, less than 1.2 between 550 megahertz and 3 gigahertz, and less than 1.3 up to 4 gigahertz. The true bandwidth testing up to 4 gigahertz can really improve the capabilities of your calibration lab with the 9540C heads and the 9500C oscilloscope calibrator. Let's take a look at what one of our customers has had to say.
You would be out of your mind to not get the 9500C. And I know that sounds like an exaggeration, but as somebody who's been working on oscilloscope calibration as a test engineer for more than 20 years, this is the biggest revolution I have ever seen in the entire test measurement industry, to suddenly cut your test times by 4 times. That's a drastic change. My favorite update for the 9500C is definitely the simultaneous channels. Really being able to test our oscilloscopes as a multi-channel oscilloscope the way that a normal customer would use them makes a lot of sense to us. And it will be by far the biggest revolution for oscilloscope testing in the history of oscilloscope testing. Many years ago, we would only have a single channel oscilloscope, and then we finally moved to multi-channels, but we still had to test them one at a time. Finally, with the 9500C, we can actually test all of the channels on our oscilloscope at the same time. This is a major time savings for us. There's better connectivity on the remote side. We will be able to query when the instrument is ready to output a signal. We'll have USB firmware updates that we can do. We have a lot more status about the state of the instrument, what it's doing, and quite a bit more. So the 9500C really is expected to have much better reliability, especially around the heads. The heads get a lot of use here in our manufacturing environment because we go through so many oscilloscopes. And being able to have a replaceable BNC connector means the downtime to service those heads will be far faster. And in addition to that, they have a lot of solid-state components versus the older model that we had, so the expected reliability is going to be considerably better.
The 9500C is truly an exceptional machine. It is the most capable oscilloscope calibrator on the market today. Let's take a look at what it does. It's 30% faster. It's more reliable with field replaceable components. It supports up to 4 gigahertz. It has simultaneous output. It's fully automated. It's backwards compatible with the 9500B, and it has a faster edge. All of this makes the 9500C and the 9540C heads more efficient, more effective, and more productive than any other oscilloscope calibrator out in the market today. So it is open for orders now in the US and Canada, with EMEA and APAC to follow in the next couple months. It is priced at $64,250 for the 9500C, as well as $11,250 for the 9540C active heads, with deliveries beginning in early July. You can scan the QR code on the right to bring you directly to the product page and discover more of the 9500C on your own. While you're looking through the product, I have Erwing here on my side to give you a live demo. Erwing, take it away.
So you might see the heads. I'm gonna give you a closer look to the head on the camera. You can remove the connector. All the connectors can be swappable, so less better service inside the house. All the functions around here, so DC, square wave, level sign, skew, time markers. If you want to measure the resistance on the channel, you can do it. You can measure as well the capacitance. In this case, it should be around 14 picofarads, which is close. And then as Mir was mentioning, you can be driving all the 4 heads at the same time. So that's a lot of time improvement. You can do bandwidth testing, which I'm gonna do. This oscilloscope in this case is 500 megs. So I'm gonna try to exceed and match and exceed. So you see a big signal drop. I'm gonna use the 2 channels. So channel select, I can easily select one of the channels. As you see, the lights give me the warning that I'm actually using the head or no. You can change the load, as Mihir was mentioning, without adding the terminator. So this is 1 meg, but you can use 50 ohms as well as you need it. And I'm gonna do 200 millivolts and then use 500 megahertz. And then I see a drop on the channel, should be around 140. As you may see, as I pass the bandwidth, I get a lot of loss in signal. We already calculated about 530, so we are on the bandwidth limit, which is better than the spec on the oscilloscope. And as you may see, you see touchscreen. I can easily stop and operate. This is the same configuration we have on the 9500B. So if you have muscle memory, the key pads are located in the same place, and then you can easily remove the cables. We will add a torque wrench so you can have always the exact torque on the cables. and that's it. Wally, you want to say something that I can do in the oscilloscope right here?
It might be worth showing them what the timing markers look like real quickly, just to give them an idea how timing markers work on the instrument, and being able to see how you can measure timing, or maybe the pulse, or maybe a fast rise time as well, and how quickly and easy it is to switch around between those different test measurements.
I'm gonna close the channel 2 to have better screen here. Make it even smaller, and this is a time marker. I'm going to change the waveform and increase the trigger
there, and then you should be able to see like every 10th marker gets is higher than the other ones. So you can see where you can line those up. This is really more useful on like an analog display, an analog scope, when you're trying to line up graticules. But yeah.
Any questions from the chat already? And then if you have this equipment, you can go and identify this as a 900C or B. As Mir was mentioning, if you have the 900B procedure, you can run them, and he can be 900B in the network. You can change the name.
It will emulate a 9500B completely and has the exact same command sets. The C does have some command extensions that the 9500B did not have, but if you're running 9500B code or a system, this thing should accept that and understand it and run straight off it. The only thing that might be different is we may be executing faster in some functions than the old B did. And so if you had an application that you'd written on your own that had timing dependencies, you might want to look at that. Might something you have to test for. But beyond that, like all of our MetCal procedures should run straight off of, the all 9500B will run straight on the C. They won't necessarily take advantage of simultaneous output, but they're certainly compatible here.
Then you can use the frequency increaser. This is for one channel. This is for the sequence. You can change the deviation to UUT error, which is the opposite, depending on how you like it. We can do pulse. Got it.
Wally, there's an interesting question here in the chat.
Okay.
Is the video functionality NTSC only, or is it upgraded to newer?
It does NTSC, PAL, and CCAM, which on all of them. It also does even and odd line numbers if you want to get into that as well. There aren't the video triggering seems to be reducing as there's less and less video work out there, but we support all of the video triggering signals that we had in the old 9500B as well. So they're all there, NTSC, PAL, and CCAM. Does that? I'm hoping that answers the question that was presented.
Yeah. Will MetCal procedures be redeveloped for 9500C for simultaneous output?
So our plan is at launch, we'll certainly there will be an upgrade to a 9500C FSC that's added to MetCal to fully support the product. Then there is some support work where we will be knocking down some of the more popular scope procedures to optimize them for simultaneous output, and we will release them as 9500C procedures. Obviously a 9500B procedure being run on a 9500C since the B did not do simultaneous output, it won't be able to take those 9500B procedures won't take advantage of the simultaneous output of a C. So we're going to have to restructure those procedures and release them as new procedures for the C. And over time, that library will continue to be developed. Our MetCal team has got a fair amount of work to. There's a lot of 9500B procedures out there, but that is something that you can look forward to as we continue to get this product out in the marketplace.
There's another question around USB TMC remote communication.
At this point in time, the product only going to be a GPIB and LAN interface. The USB is not supported as a communications interface at this point, and I'm, from a product standpoint, I'm a little bit at a loss to whether I would do that, because people are usually jumping from GPIB over to LAN interfaces. But if there was enough need in marketplace, we obviously have the hardware in place. It's just a matter of us actually putting in the USB test and measurement class drivers into the instrument. But at this point, we don't have that on our roadmap. Other questions that we can field?
Does the D-SKU feature work the same as 9500B?
Which feature?
The D-SKU.
There's a little bit of a change that we've done with D-SKUing, and actually we've improved it a little bit. So in the past, you could line up channels and D-SKU them from channel 1 through 4. There is that same configuration in the setup screen. In the past, though, that was a volatile setting in the 9500B. So that the minute if you powered down your 9500B, it would lose that SKU, that SKU configuration, and you'd have to readjust it and reset it up. And it is a little bit unique from head to head. But as we've made that a non-volatile setting, so that if you've set SKU up once and you don't change hardware configurations from head, move heads around on different channels, that same SKU configuration will still be valid and usable, and it will survive a power cycle. So you don't have to continue to change that SKU every single time you power up an instrument and reset it. So that's been an improvement that we've made.
Wally, there's a ton of questions regarding the frequency range and how we landed at the 4 gigahertz for this product.
4 gigahertz, there's a little bit of some of our own internal design hardware limitations in there, as well as a broad look at the scope marketplace in terms of what UUTs that are out there. The 3.2 gigahertz on the old B version was kind of a no man's land. From if you looked at the scope markets, the scopes that are out there commercially, they generally would land at cardinal numbers of 1, 2, 4, or 5. And so you'd see, a 1 gigahertz scope, a 2 gigahertz scope, a 4 gigahertz scope. Then the next jump would be at 5 gigahertz or 8 gigahertz or 5, 8, 10. So we're obviously not going to handle those 5, 8, 10 gigahertz scopes, but below that, we're certainly going to be capable of it. The workload that's out there still is vast. There's still a large majority of scopes that are in the 500 megahertz to a gigahertz range, which we certainly have plenty of bandwidth here with this product to address the lion's share of scopes that are out there being used today and deployed today. There's certainly always a push to get higher frequencies, but at this point, we're with this product is 4 gigahertz seemed to be the sweet spot from a commercial workload standpoint, as well as a technical capability standpoint as well.
And I think there's a last question of where these are being manufactured. These will be manufactured in our facility in Norwich, not here at the
exactly the same location where our 9500Bs are manufactured today is in our Norwich facility. Correct. But we will have service capabilities set up here in the United States, Singapore, China, Japan, and Europe, Eindhoven. So we'll have service centers in a variety of locations as well.
Yeah. All right. I think that's thanks again for Eric for answering all the questions there, Wally. We had some great ones. There's one last one came in. There's can the external auxiliary input be routed to multiple channels at the same time? If so, can a phase or time delay be introduced between the channels?
No, it's a one-to-one. So you could put a signal generator on the aux input and route it through to one head at a time. But whatever you have on that output, you could do so, or that input, I should say. You could route to any one of the 5 heads if you want to really think of the 5th head being the trigger channel as well.
All right. Thanks again for attending the 9500C launch webinar here today. Again, we have the QR code here on your right that you can scan and go directly to our website and browse through all of our different blogs and information and view those videos again, some excellent ones that the team developed. Again, we're happy to, our sales team is happy to reach out and answer any questions and introduce yourself, introduce the product to you. So please do so. And yeah, thanks again for coming out and for the launch of 9500C. Thanks, everyone.
Thank you, everyone.
Thank you.